picture of the Kohala mountain range in Hawaii. Now you may notice that the top part of the mountain is very lush and green, almost like a rainforest. However, the bottom part of the mountain is very dry and arid, almost like a mini desert. Now, what if I told you that this was not caused by a landslide or a forest fire, or even by something like deforestation? In fact, this is actually caused by a phenomenon called the rain shadow effect. Now, in order to understand the rain shadow effect, we first need to understand a process called adiabatic heating and cooling. Typically, when you think about temperature change, you're probably thinking of diabatic heating and cooling, meaning the addition or removal of energy from a system to change the temperature of a substance. But what if you could heat something, in this case air, without the addition or removal of energy? This is what I meant by earlier when I mentioned adiabatic heating and cooling. But how is this even possible? Well, it relates to something you probably learned in a first-year chemistry class, gas laws. We know two things. One, that pressure and volume have an inverse relationship when it comes to gases, and two, that pressure decreases with altitude. Let's imagine a parcel of air. As it moves up into the atmosphere, the pressure on it is going to decrease. In order for this to happen, the volume of the air is going to expand to allow for less particle collisions. And because of that expansion, the temperature of the air is going to decrease, as the heat from this original parcel of air is more spread out. This is called adiabatic cooling, and the reverse is called adiabatic heating, when air is compressed. Overall, we call this a Hadley cell, and it's an air circulation current found around the equator. The concentrated sunlight in this region makes the air very hot and moist, so we start with this cloud of warm, wet air right here. Because hot air is lighter than cold air, this cloud will move up into the atmosphere where it will undergo adiabatic cooling. Because air condenses when it is cold, rain is going to form. Now, once the cloud has wrung itself out, we are left with very cold, dry air. Now, once again, because cold air is denser than hot air, the cloud will sort of fountain out to the side and begin to sink. As it gets closer and closer to Earth's surface, the cloud undergoes adiabatic heating, blasting Earth's surface with hot, dry air. If we look at a map, this is why we have deserts at the 30-degree north and 30-degree south latitude lines. Let's go back to our Hawaiian mountain. Now, it's not like Hawaii lies right on the equator, so why do we have such a stark line between the desert and the rainforest? Well, adiabatic heating and cooling actually plays a part in causing the rain shadow effect. Warm prevailing winds from the ocean blow into the windward side of the mountain. As the air blows over the mountain, it is forced up, undergoing adiabatic cooling and forming what is called orographic precipitation. As it summits the mountain and comes down over the other side, the now dry air performs adiabatic heating, blasting the leeward side of the mountain with super hot, dry air, thus forming a rain shadow. And there you have it. Now you know why you can have two completely different ecosystems on either side of a mountain. Thanks for watching.